Hello, everyone, and welcome to this Telit webinar, How to Add Multiple Technologies to IoT Solutions and Get to Market Faster. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating today's event. First, let's get to know our speakers. To explain this topic today, I am pleased to be joined by two Telit speakers. First, we have Carmelo D'Agostini, Product Manager at Telit. Hi, Carmelo.
Hello, everybody.
Second, we have Gianmarco Zonda, a Product Manager at Telit. Hi, Gianmarco.
Hello, Amanda, and hi, everybody.
Just before I hand it over to start the presentation, I do have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of our presentation today. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for some additional information on today's topic. Finally, we will send out the replay link to all attendees at the conclusion of this webinar. One last thing before we start, we would like to understand your interest in multi-radio technology use in IoT applications. If you could take just a second to fill out the poll question, which you'll see on your screen now. And with that, Gianmarco, I will hand it over to you to start our presentation.
Thank you, Amanda. Today, we'll focus on the following agenda. I will start with a brief introduction of Telit offering and portfolio, then move into the IoT design strategies, and finally, we will move to the core topics of this webinar with the two sessions about the short range and location integration led by me and Carmelo. As you can see in the ecosystem diagram in this first slide, Telit is at the core of the IoT and is recognized as a leading enabler of the Internet of Things. Our offering ranges from actual devices up to services for companies, large and small, that all rely on mission-critical connectivity, security, scalability, and focusing on enterprise-grade performances. Telit IoT module products and IoT connectivity and platform services enable end-to-end IoT deployments from things to apps. You can use our module, connectivity and platform separately, or bundled together as an integrated end-to-end solution, reducing complexity, risk, and of course, time to market and costs versus trying to engineer your own homegrown projects. In addition to what we are showing here, Telit secure embedded software and platform enable also Azure, AWS, and Google Cloud Platform integration, as well as a variety of application and service systems. Finally, the edge hardware is the foundation of the digital-first and absolutely connected paradigm, offering an all-in-one integration of all Telit services. I'm referring especially to Telit One Edge that allow our modules with edge hardware to integrate and add a layer to monitoring, connectivity, and data analytics for your application. That said, I am now to Carmelo that will start the next session.
Thank you, Gianmarco. When you start developing your solution, you have to keep in mind several aspects that could have impact on the time to market of your product. We can probably group these in two main areas. From the pure design choice, for example, the form factor of your device, of your device, the antenna that you would like to use. That, of course, depends on the connectivity need that your product has. In which geographical area you plan to deploy your solution, and which connectivity technology you are planning to use. Of course, according to the connectivity needs, the power profile of your device will be different. hence, you have to plan accordingly for what concern, for example, the recharge strategy, if your device is battery powered, or if it is connected to a main line. We can tackle all these challenges using different strategy, as we can see in this simplified graph. On the top right, we can have the chip-down design approach. This for sure gives you the maximum flexibility, but the cost in terms of project complexity and time to market will be for sure very high. On the contrary, here on the bottom left, we have the off-the-shelf box solution. Here, time to market and complexity will be very low, but for sure you don't have a lot of room for differentiation with respect to competition. Finally, in the middle, we can see the module-based approach, the one that Telit offers, where having a precertified and pre-validated connectivity module could place you in the golden spot for development in terms of flexibility and time to market. Now, once you selected your main strategy, you have to consider what would be your product connectivity needs. For example, there are several questions that you have to ask yourself. And one of that could be what region your device will be deployed. It will be regional, globally, or just in some area. If your device will be used mostly connected to the main line, or it will be mobile. How much data your device will consume? So will you need a very high bandwidth device or connectivity, or very low connectivity in terms of bandwidth? How many devices nearby that need to be connected to your device? So basically, will be it a point-to-point approach or mesh type kind of connectivity? And last but not least, if your device will need the location services. So there are all these questions that will help you select the right connectivity solution for your device. Furthermore, if we think about nowadays IoT market, we can say that almost 100% of the solutions are fog solutions, meaning that they don't rely on a pure cloud architecture and connection, but the smartness is shared between the edge devices, the gateway, and the cloud. And then each one of these elements of the solution implement one or more connectivity technology, some such as the one that we can see here in the picture. So, for example, we have low bandwidth and very low range technology like RFID or NFC, or going up on the range and the bandwidth, we can have 5G cellular connection. So we have all the possible range or bandwidth and range in the middle. Now we are going to focus a little bit more in detail on short range and cellular integration, and we'll see what can Telit offer you to speed up the time to market. When we talk about short-range technology, a standard in Telit, we can refer to different technology. So we can go from Wi-Fi, that for sure is a high bandwidth, to Bluetooth, a lower bandwidth, going Wi-Fi ultra low power, the EAH standard, and then going to Zigbee trade data wave or Matter standard, finally finishing to the Bluetooth LE, so Bluetooth low energy, that for sure have a lower bandwidth and lower power consumption. Of course, each of these technology has its own characteristics in terms of power consumption, range, and number of nodes that can be supported. Now, I would like to analyze some real example of solution where multiple connectivity technology are indeed used and implemented. One first example could be a gateway between a Bluetooth Wi-Fi and then that works like a local endpoint, and then this device will offer cellular connectivity for the internet, for example. A second example could be a device that uses the Wi-Fi connectivity as default, and then switch to cellular connectivity when it is out of range from the Wi-Fi. Third example could be a device that offers cellular connectivity as a standard, and then by the means of BLE can offer provisioning or configuration of the device itself. Finally, one last example could be an asset tracking device that can offer cellular uplink and then adds precise indoor location via beaconing Wi-Fi or Bluetooth. When we talk about multiple wireless technology, however, we have to talk about coexistence. In other words, the ability for multiple protocols to work together in the same product without significant degradation of either operation. We should take in consideration the coexistence aspect during all the phases of our device design, starting from the size and shape of the product itself, how we'll design the RF board, where we position the antenna, how we develop the software, to the regulatory approvals, as we are going to see later on during this webinar. I would like, anyway, in this short webinar, to talk a little bit about what happens to performance and the degradation that could happen if the coexistence of multiple wireless technology are not planned in advance, and how Telit could help you to reduce those risks. Everything theoretically could be easier if we start the good question from the beginning. Such question could be, for example, knowing your real needs. What is the output power of your device? Which frequency bands are used, or if there is any harmonics that is created during a transmission? If during your design you have space for some hardware filters in order to reduce interference between different technology. Another interesting question is what is the real user case? In the sense, in your design you can have multiple technology, but your final user is going to use them all together at the same time, or we can simply switch on and off one technology in order to have better performance. Antenna selection and its bandwidth again is very important. And finally, also the geographical area where you plan to deploy your device is relevant in this case. For sure, there are some best practice. For example, going through what Telit can offer. So a module-based design can definitely help, since modules are pre-certified and pre-validated. And this can help during down in the path for the regulatory approval of your final devices. And of course, Telit can also help you during all your design phases, helping you with the antenna selection strategy, helping with the RF design path, define the software strategy, and what will be the certification strategy, as we are going to see. Just to give you another short example that I was mentioning before, antenna position and radiated pattern is for sure something really important to reduce coexistence. Another idea could be software control, so that we can select which technology is transmitting at a certain point in time. I would like to finish my presentation with two examples of products that Telit can offer that are basically bundle of our modules that offer different kind of technology. The first one is composed by the ME910C1, that is an LT Cat M1 narrowband module, in a bundle with the EE310G4, that is our latest Wi-Fi ABGN plus Bluetooth 5 module. Here I've shown two different configurations. In the first one, basically, we have our ME910 that will work offer cellular connectivity, and at the same time, you have our EE310G4 that can work as a station for a local network. The EE310G4 at the same time can offer Bluetooth connectivity for a local network. On the right, there is another possible configuration of this bundle of devices, where only the ME910C1 will have internet or cloud connectivity, whereas the EE310G4 will work only on the local network, offering access point to local endpoint devices via Wi-Fi or Bluetooth. The next example, in this case, is a second bundle that Telit can offer you. In this case, is based on the LE910CX module, that is LT Cat C1 C4 module, plus WE866C6, that is our Wi-Fi ABGN AC plus Bluetooth 5 module. Again, also in this case, different configurations are possible, quite similar to the previous case, where you have our cellular module that have cellular connectivity to the cloud, and our Wi-Fi module, Wi-Fi to Bluetooth, that will manage the local network, or via gateway can connect also to the cloud, to the internet. And in configuration 2, you have again the LE910 that will work as cellular module, whereas the WE866C6 will work as access point for a local network. And with this, I will leave the stage to Gianmarco, that will continue the session.
Thank you, Carmelo. I will now be focusing a little more on the location technologies. That is my area of expertise. In particular, trying to talk about GNSS positioning and location technologies in general. So, what you need for location technologies? Several modern services and applications are now location dependent. We can think, for example, about services available only in specific countries or city, or the automatic configuration of the device based on a specific location or area, or even the e-mobility services like scooters and other vehicles, and with definition of allowed and not allowed areas for their function, for their usage. All these services are, of course, dependent on the location. So obtaining the device position is a must-have for the majority of the IoT application, and that can be achieved via different technologies with, of course, different levels of accuracy. In particular, retrieving the cell tower information and sending this information to that specific database can provide a rough estimation of the position that usually ranges from a few kilometers to tens of meters. And we do offer this kind of services through Telit portal. Or if a more precise location is needed, using a GNSS receiver, so GPS or in general satellite receiver, as a standalone or embedded, can provide position information with accuracy in meter, at meter, or even sub-meter level, depending on the specific use case. So, that said, understanding your use case, as Carmelo in the first part of the session said, and achieving the desired accuracy level required correct integration of all these technologies together. I will highlight then a few of the very common use cases for positioning technologies that often require the integration of cellular or other radio technologies for communication or reporting of the position. You can see, for example, the dash cams and similarly also the insurances black boxes are devices that continuously monitor position, and they need occasional need for uploading this information to a provider, to some service provider of the insurance itself, either for monitoring the driver behavior, the video recording, or for reporting a car accident or a specific event that triggers this communication. Similarly, also fleet tracking use case requires frequent or continuous tracking of the position to ensure that the vehicle is used correctly and in the correct area, and this position information usually is reported more often for a correct monitoring of all the fleet. Also in this case, the required accuracy is usually at meter level, so GNSS device needs to be integrated into this kind of application. Thirdly, asset tracking, that also can be, let's say, low dynamics tracking, applying also to pet or person tracking, is a periodic tracking with low dynamics where only occasional position is needed with maybe accurate position, so like using a GNSS, but the reporting of it is not very frequent. Finally, the fourth case is what I was mentioning before, all the location-based services, kind of services that require the location to provide additional services or augmented services related to the position. It is a little more general, but that is, let's say, including the cases that are not tracked by the first three elements. So, how to integrate the GNSS, or let's say a global navigation satellite system, into your application. Also in this case, there is a coexistence problem that need to be taken into account. And as Carmelo reported before, we consider coexistence the ability to operate in the same frequency band without significant degradation of to either operation for multiple devices. GNSS receivers, as the name said, are pure receivers. So why do we need coexistence? They don't have a radio. Why should you take that into account? But however, although there is not a real radio on it, the other radio can impact the GNSS performances and capabilities, and if the antennas of the devices are not correctly isolated or separated, there may be some harmonics or signal that are received and retransmitted by your GNSS, by the antenna of your GNSS, making it a background noise or an issue for your full application. So, as Carmelo was saying before, I will, instead of focusing on all the design suggestions that already has been highlighted, I would like to focus a little more on the performance issue that may affect the GNSS, and then on the regulatory approvals on your final device and how that can take GNSS into account. In fact, the majority of Telit cellular now have an embedded GNSS device on it, or depending on your application, you may want to use an external GNSS module. There are few advantages of each solution, especially the embedded GNSS on our cellular device offer a unified interface with the ATI commands. It has a mid to high power consumption because the cellular part usually needs to be on for controlling and keeping the GNSS active. But it also it is a self-contained solution. It offers all the standard GNSS features, and all the technologies, both cellular and GNSS, are already approved in the same module. So for your application, it's smoothly the integration into your final product. On the other hand, the external GNSS offer a higher grade of flexibilities, offering two interfaces. One is the AT interface of the cellular, and the other is an NEA interface for the GNSS module. Usually it has a better and lower power consumption, since the cellular part can be completely switched off when only the GNSS is in use and be independent. And here again we get back to the software and firmware strategy for your final application, where if you need to use the GNSS independently, or if power consumption is your concern, your strategy should switch off the part that's consuming the most when it's not needed. Of course, it requires some additional design review on this to achieve the optimal performances, but it allows to have some advanced GNSS features available only on the GNSS standalone devices. Also, as for the US customers, FCC is not required for GNSS modules since they are pure receivers. However, other regulatory may be and may apply to different regions, and so should be considered also for these modules. Here is a very brief schematic of an application with embedded GNSS case, where we can see an LE910C1 or CX, that is either one of two or four, that integrates Wi-Fi and Bluetooth, GPIOs, and all the other devices, but where we can add a GNSS just by adding a GNSS antenna. It is possible to achieve GNSS and location capabilities directly on the cellular device. However, since both cellular and GNSS needs to work on the same application, depending in this case having the cellular always on, the antenna should, for optimal performance, should be maybe an active antenna that integrates a preselection filter to avoid that signal from the cellular or other radio, like the Wi-Fi and Bluetooth in this schematics, interfere with the GNSS performance. In case an active antenna is not needed or is not applicable for the customer use case, a passive antenna with a pre-filter stage and an LNA can also be taken into account. Of course, that depends on the final application design, where the interference of the antennas and the antenna position in distance may reduce the need of these additional stages. Also, if this stage is not needed on the application board, customer may also have bypass this pre-filtering stage by adding a capacitor. So only if the application requires it, they can have a mount/no mount option for this pre-filtering stage. Also, because this pre-filtering stage usually may introduce some insertion loss. In case of an external GNSS case, as I was saying before, there is the requirement of two interfaces. So the host MCU should control the GNSS receiver and the cellular, while the cellular is in a bundle with, or maybe in a bundle with the Wi-Fi or Bluetooth technologies. And in this case, the considerations are very similar, but if, for example, like in this picture, choosing an antenna module that already embed an antenna, customer can already have a design that integrates a preselection filter or that doesn't depending on the chosen module. So in this case, the 878 integrate this pre-selection filter. So as for moving forward with the consideration that I highlighted before, all these integration for both short-range technologies and GNSS technologies can be supported by our design review and pre-certification teams at Telit. In fact, Telit offers to its customers the design review service for quickly achieve the optimal design of the desired use case. That include, as highlighted in the slide, both schematic and PCB layout review, supporting for the component placement and component selection, including measurement of characteristics of integrated antenna and system architectures. And in case of certification, where certification is involved, we have a pre-certification testing service that can help to measure the radiated spurious signals on your application. That's why we recommend to test all the full application with all the technologies there, so that if one of them interferes or there are some harmonics, that can prevent the path of a specific certification approval that can be promptly highlighted and corrected before going to markets and so before going to certification. So both of these services can help in early identifying any issue with multiple technologies on your device. Finally, I will spend a few words on the coexistence and certification issues you may face. In particular, for speeding up certification phase, it is recommended to start with a module design, since that will help in reusing your cellular, wireless, or GNSS reports and results for speeding up the certification of your final application. In addition to that, our pre-certification services can spot additional coexistent emission on your application that will prevent any false or any delay in your certification phase. And in particular, regarding the regulatory approvals like FCC or ISED, that is simplified when using a pre-certified module. For example, for the FCC in the US, the change it will require only a change of identification instead of a full FCC activity, while for the ISED that will be a multiple listing, just another listing of this technology, like with your application. That said, I think that's all for today and for my presentation. So I hand to you, Amanda, for any questions we may have received in the meanwhile.
Great. Thank you so much, guys. Really, really good information here. Before we get to our audience questions, I am going to drop just one last poll on your screen here. If you would like to have one of our experts contact you directly, please respond here on the poll and we will have someone reach out. We do have time for a few questions, and there's still time to ask a question, so please feel free to submit using the box to the right of the slide presentation, and we will do our best to cover it here in the time we have left. We've gotten quite a few questions, so I'm going to just jump right in here. First question I have, you mentioned that coexistence could have an impact or not, depending on the geographical region. Could you please give an example?
Yes, I think this question is for me. So basically, there are some some region of the world where some bands are not used. This means that, for example, if you have a device that uses LTE and Wi-Fi in US, the Wi-Fi could use band 7, since in USA this band is not used. So this, for example, simplify the management of coexistence of these two technology in your design. Okay.
Great, thank you. Next question. What are the main differences between embedded and external GNSS, and why should I choose one or the other?
Thank you, Amanda. I think this question is for me. The main differences are mostly in the use case, I think, and that is what should define how to choose one or the other. But as I was highlighting before, the embedded GNSS requires the cellular section and the cellular to be always on, or at least on idle, leading to a higher power consumption, usually, than a standalone. On the other end, the main difference with the external one is that the external GNSS can be controlled independently of the cellular, and if your strategy requires a very frequent or continuous GNSS connection, but very few cellular interactions or other radio interactions, then an approach with an external GNSS is to be preferred. While if your cellular or other radio technology may have to stay on very often, then the simplified approach of an embedded may be preferred. I hope that answered the question.
Great, thank you. Next question that we got here says, I am already designing an application with multiple technologies, but how can I get help with the certification process?
Carmelo, I think I take this one.
Yes, please go ahead.
So, as I highlighted in the last part of the webinar, we offer two main support for our customers. That one is the design review stage and support, and the other one is the pre-certification service. So if a customer is already if they already have design, my suggestion is to as soon as possible submit a request for design review to be sure that the design is certification safe, or at least that in terms of placement, component choice, and all the things that can be defined before the real certification phase can be addressed and corrected on time. While if the design is already completed and the customer already followed the right steps, they can apply for pre-certification services, confirming that their application is already passing or aligned with the certification requirement.
Great, thank you. And if any audience with these questions, if you have a follow-up, feel free to send that in as well. All right, next question I have here. Could you please give more detail on how software control works when you have different wireless technologies in the same product?
Yes, I think this question, I can try to answer this question. So basically, I touched briefly during my session, my part of the presentation, but I will go with a practical example where, for example, if you use our LA910 module bundled with our WE866C6 module, so the LT module with plus the Wi-Fi module, those modules are made to work well together, and this is where Telit offering shines, because using these two modules together, if you remember in the slide, I showed that they use the UART or SDO interface to communicate between each other. But these two modules also have some coexistence port that gives the possibility to the two modules to communicate between them and coordinate. So in this case, for example, if the LT module is transmitting, can send a message to the Wi-Fi module to say, please wait and resume as soon as I finish. And vice versa, if the Wi-Fi module is transmitting, you can set the priority and decide if the cellular mode has to take priority and start transmitting, stopping the Wi-Fi, or just let the Wi-Fi module finish. So this is something that can be easily programmed. And again, this is one of the advantages of using this kind of bundle where you have multiple modules, multiple technology working together, and everything is already being pre-certified and tested for you, speeding up your time to market. Okay. I hope that this clarifies this point about software and how you can help you in this situation. Is there any other question in the audience?
Yeah, I think we've got time for just one more, and it's kind of a follow-up, I think, to the last question that you just answered. But what are some of the other advantages of using certified modules? And I know you kind of just covered that, but maybe you could give us a couple more examples.
Sure, I can take this one. Thank you, Amanda. As I was saying, in general, what happens with the certification phase is that the customer needs to provide to a test house their application, and they need to perform a series of tests that are usually costly and time-consuming. While having a module that is already certified for a certain specific regulatory approval means that the Telit can provide to the test house chosen by the customer all the test reports that has already been performed on the module, and that can cut the time of their certification process, and it can also help in reducing the cost, since these tests are not needed. Then the final is, of course, the customer need to get the approval for their final application, but having this modular approach helps in reducing the effort for the test house and the required time to market. I hope that sums up this question.
Yep, perfect. Thanks. And we are actually coming up on time here, so I believe that's all the time we've got for today. Audience, please be sure to check your inboxes in the coming days, so we will send out slides and replay link. Carmelo, Gianmarco, thank you so much for this great presentation today, and thank you all who joined us. Have a great one.
Thank you, everybody.
You too. Thank you. Thank you, everybody.